So today we will discuss about NEET JEE solid state. So solid state, some important points we will discuss about. See, in that NEET and JEE they will ask V's and Miller indices. V's indices. So that is indicated with ABC. So if we want to construct one crystal means the important points are what edge length. So x-axis, y-axis, z-axis. Suppose x-axis edge length is A. So y-axis edge length is B, z-axis edge length is C. So that is indicated with ABC, V's indices. Suppose we are constructed in x-axis 1 unit, y-axis 2 units, z-axis is nothing. So this V's indices become as from 0, 1, 2. This is not constructed on z-axis. So that's why they are taken as infinity. That way. So in V's indices, what happens? The values are coming as negative also available. So positive also available. Next, they are not constructed means infinity value also coming. Next, fractional values also observed. So this meaning is from the origin, some one wall we are constructed on this much distance. This wall is lifted on y-axis. This wall is observed on the z-axis. Like that construction. Next, the Miller indices. So here what happens, negative values, that fraction values, infinity values are there. So try to control that one. Negative fractions, they are taken as next Miller indices. So Miller indices. So that is indicated with HKL. Say, suppose we have minus 1 by 2. Minus 1 by 3 infinity values are there. So this is what V's indices. So how to convert it into Miller? So these are minus is there. Suppose you multiply with minus. So that values are become as 1 by 2, 1 by 3 infinity. Next, infinity means what? We are not constructed anything on z axis. So not constructed means better one you take 0 is the better. How infinity is become a 0? You take reciprocal. So you take a reciprocal values. So that means what? 2 by 1. Next 3 by 1. Next 1 by infinity. So that means the values are become as 2, 3, 0. So this we called as a HKL. So that means from x-axis it is a 2 distance, y-axis 3 distance, z-axis we are not constructed anything. So this is how to convert V's to Miller. Next, the importance of HKL, Miller indices means one formula they can ask. The distance between, suppose the crystal is like this, parallel. So that means the distance between two successive layers, you can take DHKL. So the formula is also there, DHKL equal to edge length by under root of H square plus K square plus L square. See, the Miller indices, it is based on theory. So theory basis that Miller indices for simple cube BCC FCC. So simple cube, S means simple cube, B means BCC, F means FCC. So what are the Miller indices for simple cube? That is 100 here, 110. Next third one, triple one. Next BCC. that is, you take 200, next 110, next 222. So for FCC, that is 200, 220, 111. See, once previous they asked the sum of the Miller indices of which crystalline structure is the even number. So here 1, 1 plus 1, 2, here 3. 2 odd numbers, so 1 even number. So 2, here 1 plus 1, 2, here 6. So your answer is BCC. The sum of the Miller indices become as even number. So that is. Next, the same here, the DHKL. So the distance between two successive layers in the crystalline. So what is that? A by under root of h square plus k square plus l square. So that is. Next here a by under root of 1 square plus 1 square. That means a by root 2. Next here the DHKL is what? A by root 3. These are. Next BCC a by under root of 2 square plus 0 square plus 0 square. That means what? A by 2. Next here a by root 2. Next, so a by under root of 2 square plus 2 square plus 2 square. That means what? A by 2 root 3. Next here a by 2. Next here a by 2 root 2. This is a by root 3. Suppose they will ask this one. Next, according to theory, the Miller indices previous we discussed. Now distance between two successive layers also we discussed. Next, the same values experimentally explained by. So that experimentally this is explained by Bragg's equation. So what is Bragg's equation? N lambda equal to 2d sin theta. So upon crystal we are sending some frequency of light. So based on that d value is identified. Experimentally d value is identified. This is a theoretical manner. So what is Bragg's equation? Say the crystal structure is in the form of different layers. We are sending light, so it will be diffracted. So it is a diffraction of light experiment actually. Diffraction of light experiment. Next, suppose second it is traveling. So first one, second in different layers. So compared to first light, second light is more powerful. So it will penetrate into the second layer and diffracted from that. So based on this, that extra distance traveled by these things, based on this mathematical, they can provide this one. So here lambda is the wavelength of this one, n equal to the value, the diffracted, n equal to diffracted light. So that is one fold, bifold or threefold, like that they will mention that number. D is the distance, T is the angle we are sending the light on the surface of that one. So theta is angle. So this is also very important in the problems they can ask. See, whatever the D values, what is the D value here you can take means n lambda by 2 sin theta. See, previous we discussed simple cube, BCC, FCC. What are the D values? You are coincide here. So based on that we can explain. So in this experiment what we are doing, the crystal we are taking. So the crystal is focused with suitable light See, from 0 degrees to 180 degrees, we are focusing light. So this is a minimum angle is 0 degrees, maximum is 180 degrees. We are focusing this light with different angles. And lastly, we are find out the DHKL. So HKL means theory, Bragg's equation is experimental. Whatever we discussed previous, exact values of this for simple cube, BCC, FCC. Next, so in the NEET and JEE, so first coordination, second coordination, third coordination also they will ask for the unit cells. So that you can take simple cube. Simple cube, first coordination, second coordination and their distances, third coordination distances, and that values also. Coordination and distances. So simple cube. Simple cube means one corner. First coordination is next corner only. So that means corner value is 6. So that distance is A. Next, second nearest is what? That face diagonal value. Face diagonal means that is 12. The distance is root 2A. Next, third nearest distance is what? Body diagonal. Body diagonal point means that is 8. That is what? Root 3A distance for simple cube. Next, you go to BCC. So BCC means that body center is 1. Next, every corner is 1. First distance is body center. Body center means that is 8. Next, the distance is what? Root 3A by 2 distance. So second one is what? Corner point. Corner point means 6. Corner means 6. That is what? A distance. So third nearest distance, that is what? Face diagonal. So face diagonal is what? 12. So face diagonal value root 2A distance. Next, FCC. FCC means face center point, corner points. First nearest is what? Face center. Face center means that is 12. So that is what? Root 2A by 2. Otherwise, A by root 2 value also. Next, second is nearest is what? Corner only. So that is also 6. The distance is A. Next, what? Face diagonal point. That is what? 12. That is what? Root 2A. So in C, that NEET and JEE, they are asking about first, second, third, that values and their distance values, coordination also. Next, in the unit cells here, hexagonal is extra point. So hexagonal unit cell. So you can take that. This is hexagonal unit cell. It has 12 corners. So middle 3 body centers, face centers are 2. See, in hexagonal crystalline structure, we have corner points plus body center points plus face center points. See, corners, we have 12 corners. 12 corners and their contribution. See, these are connected with another. So this face we are adding another one. This face we are adding another one. So bottom is completely blocked. So with 3. Above also 3. Total 6. One corner is contributed 1 by 6. Means one corner is connected with this type of systems surrounded with 6 members. Next, body center, they are not touch with anybody. So 3 into 1 only. Plus face center, this is one cylinder. Above also you put one more cylinder. So then what? It will be blocked. So 2 into 1 by 2. So that means here 2 plus 3 plus 1, total 6. Total number of atoms in hexagonal structure is 6. Next here another important the percentage of packing fraction. So it is similar to FCC, that is 74 percentage. Next void or gap percentage, so that is what, 26 percentage. Next in the voids some important point, the radius of tetrahedral void by the radius of sphere. So that value is 0.225. So this much of radius ratio value is there, means that only it is perfectly fit in the tetrahedral void. Next one more, octahedral void radius divided by sphere is what, 0.414. So the sphere and octahedral void ratio is this much, then only that is perfectly fit into that gap. Next, in the problematic, they will mention in FCC structure and BCC structure. So, some are occupied corner points, so some are occupied at face center point, body center point. Next, they removed some elements. Then what is the formula? So, like that, they will ask a compulsory question. Suppose in what way you can see in FCC structure. In FCC structure, A occupies the corners. Next, B occupies the face center. And one face diagonal atoms are removed. Then what is the formula? So whatever this type of problems, all you must have perfect with that compulsory question, whatever the in higher entrances. So here FCC structure, you write down FCC structure. So what there, A is connected with corners. So corners are A. B is what, center. So this is A. This is B. So face centers are 6. Face center. So what they are telling that here face diagonal atoms are removed. Face diagonal atom means what? A, B, A. These atoms are removed. So here A, how many are there starting? 8 corners. Next B is what? Face centers. These are 6. So now we are face diagonal is removed. Face diagonal is removed means 2 corners gone. 2 corners gone means your answer is here 6. Next one body center is gone. So your answer is 5. So now what is that? 6 into corner is what? 1 by 8. Here 5 into 1 by 2. So this is the ratio. So that means 6 by 8 is to 5 by 2. So otherwise you can take this is what? 3 2s. So 3 2s by 4. 3 by 4. Now the ratio is 3 by 4 is to 5 by 2. So now fractional value converted into fine value. So it is multiplied with 4. Multiplied with 4 means 4 cancel. So you are getting 3 is to 2s are 10. So what is the formula? A3 B10. So like that. So many problems means in entrance compulsory question like this. Suppose they removed either face diagonal, something they will tell one face you remove means 4 corners, so one face center. Otherwise body diagonal is removed. Body diagonal means what? 2 opposite corners only we can remove. Otherwise one plane is removed. So that means four corners, so two face diagonals they are removing. So like that they will ask problems. You must concentrate this one. Next, here important is one more ionic crystals. So ionic crystals means ionic compound that contains positive ions are there and negative ions are there. So here radius ratio is important. So the radius ratio is explained, so coordination number as well as structure. So many concepts that are explained. So the radius ratio we are taken as R equal to cation radius by anion radius. You called as radius ratio. So here in different manner, if the radius ratio value less than 0.155, next another one, the between 1552 0.224, 0.224 to 0.414, 0.414 to 0.732. Again repeat, you take 0.414 to 0.732. So 0.732 to 0.999. That ratios. So here coordination number. So coordination number also explain this radius ratio. This is 2, this is 3, this is 4, 4 of sp3. This is 4 of dsp2 type. Next here it is 6, this is 8. So their examples of structure. So two member means what? Linear. So you take BEF2. Next 3 trigonal planar. So you take B2O3. Next tetrahedral. So tetrahedral means zinc sulfide. Zinc sulfide is the best example with tetrahedral. Next DSP2. DSP2 means 4 coordination number, but the structure is square planar. Square planar structure. So PTCl4 minus 2. So you can take that example. Next, so 6 means that is NeCl, crystalline structure. Next, this coordination number is cesium chloride. So this is also very important in entrance. Suppose cesium chloride, what is the radius ratio? In between these two, your answer will be there. Otherwise, they will mention this one. Structure, they will tell. What the coordination they can ask. What is the example they will ask. So everything, one important question here. So in the ionic crystal, AB type. So AB type crystals. AB type we have 3 are there. So NaCl, cesium chloride, next zinc sulfide. So zinc sulfide we have zinc blend. Zinc blend is there. Next ZnS, that is woodside structure. So what that means, the A coordination number is same, B coordination number. So that is 1:1. NaCl means, so that is 6:6. Cesium chloride is coordination number 8:8. Zinc blend, that is 4:4. So zinc surrounded with 4 sulfur, so sulfur is surrounded with 4 zinc. Na surrounded with 6 Cl, Cl is surrounded with 6 Na. Cesium is surrounded with 8 Cl, Cl is surrounded with 8 cesium. So 1:1 ratio. That's why you called as AB type. In this, many times they will ask about NaCl. So where is the location of NaCl? So NaCl, the location, Na plus is occupied octahedral voids. Cl minus is occupied FCC points. So what are octahedral void means? Body center. Body center plus edge center location. Next, FCC point means face center plus corners. So here we are discussing about NaCl. So this is more important. Many times in many exams, they will ask about NaCl only. So here Na plus lattice points. Lattice points are how many? So octahedral void means one is body center. Edge centers are 12. So your answer is 13. Next, Cl minus lattice points. That is face centers 6, corners 8. So your answer is 14. Otherwise, so in NaCl, one unit cell contains means that a crystal lattice, how many Na plus ions? How many ions? They can ask the question. So how many means, say here, body center. Body center is 1 into 1 plus edge center 12 into 1 by 4. So that is what? 4. So already we is seen. Na plus ions are how many? 4. So chlorine is surrounded with 4. Next, how many Cl minus ions? See, this face center, how many faces? 6 into 1 by 2. That contribution. Corners, 8 into 1 by 8. So that is what? 3 plus 1. So this is also 4. So that means number of Na plus ions are 4, number of Cl minus are 4 in one unit cell. So that is 4 is to 1. So 1 is to 1. That also. Next, another problem how they will ask, you write down that location. So this is also very, very important. Many times they can ask about this. Here corners. Who is corners? Cl minus. So here Cl minus is there. Here Cl minus is there. Where is the sodium? Edge center. So here what? Edge center. Na plus is there. So here to here distance you called as edge length. So edge length equal to, what is that? Here Cl. Cl is there, Na is there, Cl is there. So here to here is the edge length. So here Cl radius, 2 Cl radius. Here what? Here to here sodium radius. So 2 moles of radius of chlorine plus 2 moles of radius of Na plus. Very, very important. A equal to 2 into R of Na plus, next plus radius of Cl minus. So in this three values, Na plus, Cl minus, A, in these three they will provide 2 and they will ask third one. So very, very important. Next, in the ionic crystals, AB2 type. So previous we discussed about AB, now AB2. So AB2 contains, we have two structures. One is a fluorite and another one is anti-fluorite. Fluorite, anti-fluorite structure. So fluorite means that is a plus 2 ion. Plus 2 ion minus 1 ion. So reverse, anti-fluorite means plus 1 ion minus 2 ion. So where is the location? So 2 is located to FCC points. FCC points. So either that is either plus 2 or minus 2. That is FCC points. So already we discussed FCC point means face center plus corner points. Next, one is occupying tetrahedral voids. One is occupying tetrahedral voids. So where is tetrahedral void means every body center has two tetrahedral voids. So what will be the formula they can ask? So what is that? Calcium plus 2 means fluorine means minus 1 means CaF2. So CaF2 is a fluoride structure. Next, this is 1 plus. So that means Na plus 1, O minus 2. So Na2O. So Na2O, K2O, that are what? Anti-fluoride structure, CaF2. That is. See, FCC points. FCC points means how many? Corner points, 8 into 1 by 8. Plus face center, 6 into 1 by 2. So the FCC points are 4. Next, already tetrahedral voids we know. Every body diagonal contains 2 means totally 8. So 4 is to 8. That means 1 is to 2. Otherwise 2 is to 1. The coordination number. Next, spinal structure. So spinal structure, it is the formula AB2O4. So the best example MgAl2O4. So A, it is occupies tetrahedral void. This is octahedral voids. So this is FCC points. So tetrahedrals are 8 are there. So that's why 1 by 8. 1 by 8 of tetrahedral is occupied A. So that is what? Plus 2 oxidation state. Next, here two members. Octahedral voids are 4. So half of the octahedral voids are what? Plus 3 oxidation state. Next, oxygen atoms are occupying with FCC. FCC means what? Face centers, corner points. So they will ask location also. So another example, inverse spinal. So inverse spinal structure, that is the formula Fe3O4. So Fe3O4 contains Fe2O4. So that means this is plus 2, these are plus 3 and oxygen. So here inverse spinal, actually here plus 2 is occupying what? 1 by 8 tetrahedral. So but here Fe plus 2 is occupying octahedral. So one Fe plus 3 is octahedral, another is tetrahedral. So previous tetrahedral is occupied by plus 2, but here plus 2 is occupying octahedral. So inverse spinal example means Fe3O4. Next, some important problems. So you can see this. One, NaCl is doped with. NaCl is doped with 10 to the power of minus 3 mole percentage of gallium chloride, GaCl3. What is the concentration of vacancies? So what is the concentration? So number of the vacancies. See, this type of question, how we can take a mole percentage they are given. So 100 moles. 100 moles you are doped with 10 to the power of minus 3 moles of gallium chloride. So for 1 mole. So for 1 mole means a question mark. So it will go to 10 to the power of minus 5 moles. See, here vacancies they are asking. So 1 gallium is what? Plus 3 oxidation state. This is a plus 1. So 1 gallium plus 3 replaces 3 Na plus ions. So that means what? So one place is occupied with gallium plus 3. Remaining vacancies are 2. So it means vacancies are 2. But number of moles means 2 into 10 to the power of minus 5 moles. This much of vacancies is there. Next, 1 mole means how many number? So number of vacancies. So you can take 2 into 10 to the power of minus 5, 6.022 into 10 to the power of 23. So that become as your answer. Next, this is also one important question. So many times they are asking the percentage of packing fraction. Say already we know the percentage of packing fraction means what? Number of atoms. Number of atoms means this area. This area number of atoms means So 4 parts, this become as 1. So middle is 1. So 2 atoms will be present in that. Next, this is what? Not a 3-dimensional, it is 2-dimensional. So circle only. So that's why that occupied volume is pi r square. Next, it is edge length. So here what? This is 3, that 4r. 4r equal to root 2a. So the A edge length equal to what? Root 4r by root 2. So that means you can write 2 root 2r. See here, it is a square box. So A into A square. A square, here A equal to 2 root 2r whole square. So that calculation means you will get 78.5 percentage. This is one more. Next, another type, that metal deficient compound, they can ask the problem. So Fe 0.96 oxygen. So in this, how many? Fe plus 3 percentage is how much? Next, Fe plus 2 percentage is how much? They will ask questions. See, here one oxygen is neutralized with this much, means inside what are that? Fe plus 2 is there, Fe plus 3 is there. How to solve this problem means, suppose you take Fe plus 2 is X amount, then what happens? Fe plus 3 0.96 minus X amount of Fe plus 3 is there. So here how much positive charge is equal to the same number of negative charge. So what will be the charge, positive charge? So positive charge equal to negative charge in the molecule total. Any molecule, this is the fundamental. So positive charge 2 into X plus 0.96 minus X into this is 3. So here 1 oxygen, 1 into minus 2. So the charge is 2. So you can, this one 2x minus 3x. So x you take that side. So that means 3 into 0.96 minus 2 is the x value. So that means what? So this value is, so total that x value you will get 0.88. So that means how much? Fe plus 2 means 88 percentage. So the remaining is that Fe plus 3. So this is also one important question. Next, alkali metal, alkaline earth metals, one important. See, Lysopo lucifera, first group. Next, second group, Bemeka strawberry. So here, so first group all are BCC structure, but second group variation is there. So this is what? HCP, hexagonal close packing structure. Next, calcium is coming to FCC. Next, strontium is HCP. Next, this all are showing BCC structure. See, that's why the melting and boiling points in first group continuously, that is decreases. But here disturbance is happened because of all crystalline structures are changes. So BP and MP values are different. See, the important NaCl, cesium chloride. So what are the structures? Always we are confusing. So come out from the confusion. Sodium is metal, NaCl is what? Ionic crystal. Cesium is metal, cesium chloride is molecule. These are not equal, different. Sodium structure is what? BCC. Next, NaCl structure is FCC. Cesium is what? BCC. Cesium chloride also BCC. So here it is a very important one concept. Next, in the NEET and JEE, So we will discuss about solution. So majority all are we are discussed in previous also. Now important formulas you can take here. So here molality. Molality means small m versus mole fraction. So the formula is important. So molality equal to xb, mole fraction of solute by mole fraction of solvent into 1000 by MA. So if you know the formula means directly you can do the value. See XA means you write 1 minus XB also. One value no means automatically you can do another one also. Next, another one, molality small m versus solubility. So they will provide molality and they will ask solubility. So the molality equal to the solubility into 10 by molecular weight of solute B. Next, X percentage of solute present in the solution, and they mentioned their density also. Then they will ask about molarity, capital M. So capital M equal to 10 into density into X percentage by molecular weight of solute. Suppose the same X percentage of solute is present, the density value they are given. Suppose they are asking about normality. So normality equal to same 10 into density into X percentage. Instead of molecular weight, you write equivalent molecular weight of solute. You can take that. Next. 3 completed, I think. Next. So fourth one. So molality versus molality. So that is. So molality. That is 1 by m. 1 by molality equal to density by molarity minus molecular weight of solute by 1000. So they will provide molality and they will ask about molarity or vice versa. Anything you can do that one. Next, normality versus molarity formula. So normality equal to molarity into valency number. So that. But next, molarity capital M versus mole fraction. So they will. So here molarity capital M equal to previous 10 into D into X. So now 1000 into D into XB. So mole fraction of solute. Suppose XB means you can write 1 minus XA. That is. So divide by XA plus XB. So these are very useful formulas you can apply. These are mainly important in NEET and JEE.